Welcome to Module 3 presentation. Some of our objectives are going to be data storage, file and storage services, installing configuring file services, the file service role, specifically distributed file systems, other file service roles, disk management, basic and dynamic disks, encrypting file system, trusted platform module, BitLocker, FAT volumes, new technology, NTFS volumes, disk quotas, file sharing, permission inheritance for files and folders, basic file and folder permissions. We'll also talk about auditing file and folder access, volume shadow copy service, and shadow copies of shared folders. So under data storage, we have what's called a network attached storage, or a NAS. A NAS basically is connected through a regular TCP/IP connection. So you connect to it using your normal protocol. All server storage communications go across a LAN or a VPN tunnel. Bandwidth on the network can be shared by clients, servers, and NAS devices. A SAN, storage area network, is similar, but it works in a different way as far as connectivity goes. It is physically separated from the LAN and is independently managed. Server to storage communication doesn't affect clients and server communications. And some of the NAS or the SAN type of technologies are fiber channel and internet SCSI, ISCSI. So, what's the difference between a NAS and a SAN? A NAS is a device that stands alone. It has its own operating system on it and allows you to set up shared folders. That's all it does. You cannot install any applications on it. You can't do anything else other than install shared folders, and so you would pick your permissions, who gets access, and that kind of thing. A NAS could have a Windows NAS operating system on it. It's a special version of Windows, or it could have Unix, or it could have Linux, various different types of operating systems. A SAN, however, is not a standalone box. It doesn't have an operating system on it. It is a box that attaches to a server, and the only way that is going to work is if it's attached to a server. It can be attached to a Windows server in our particular case, and it's a box of hard drives that allows you to have a large amount of storage connected to your server. So now the SAN technology is fiber channel. So one way you can connect your SAN to your server is using a fiber connection. Basically, this is just a fiber type of a wire, same type of thing that they use in fiber optics for communicating in telephones. And it would connect between your computer and the box. There's also SCSI, which has a basic SCSI cable connection to it, which is outdated. There's not very many SCSI boxes out there anymore, but they've been replaced with something called ISCSI. So ISCSI is just a connection using an Ethernet cable. So in order to connect the SAN box of hard drives to your server, you just plug an Ethernet cable from the SAN into your server. So of the two, the fiber channel is always going to be faster, but one of the nice things about the ISCSI is it's a lot cheaper. You can get up to 10 gigabits of connectivity, even though fiber channel can go even higher than that. And the ISCSI allows you to connect instead of just to one server like you could with SCSI, it now allows you to connect to many servers. So the box of hard drives called the SAN can now be partitioned up like a pie, and you can have several terabytes go to one server, other terabytes go to other servers, instead of just one server. Under storage management, we've got volume shadow copy service. And we've got DFS. Now DFS is one of the things we'll be doing in our lab. So volume shadow copy service allows administrators to create point-in-time copies of volumes and individual files called snapshots. So the volume shadow copy service is very handy in that it allows us to go back in time in case we've got a file that was accidentally deleted or corrupted or changed in a way we didn't want it to be changed. We can now go back in time and pick a previous version, and we can restore that instead. DFS is different. It allows us to make it possible to create a single directory tree that includes multiple file servers and their file shares. So let's take a look at that. So under Tools, if you've already installed this, and if you haven't, you can do it under adding the server roles, role services. And we see under DFS management, we have namespaces and we have replication. Namespaces allows us to create a single namespace that can cover more than one server. So if we have a share called software on DCO1 and a share called software on DCO2, then if the server DCO1 goes down, people can still communicate and open files on the DCO2 software folder, and they do that using a shared namespace. So we can call this namespace whatever it is we want, and when the user tries to communicate with it, we'll just go ahead and open a notepad here. So under the old system, you have DCO1 / software, which would be a share, and you have DCO2 / software. Using DFS, we can create a new namespace, and we can just call it, we'll call it shared, for instance, / software. So it doesn't matter which server you connect to. If you do / shared / software, it'll connect to whichever server is available. So you can really get a lot of versatility using DFS and using a single namespace such as shared and a single share, but it's attached to multiple servers. Replication adds on to the DFS namespace option. Replication allows you to actually replicate software back and forth to each other. So if we use this particular example, if I have a file called help.msi, then when I copy that file into software on DCO1, it will replicate that to DCO2. And if I add a file to DCO2, it'll replicate to DCO1. If I make a change to one or the other, it'll change to the other server. So that's why you have replication, and that's why you have namespace. You don't have to use replication if you use namespaces, and you don't have to use namespaces if you choose replication. Sometimes people use replication to replicate files back and forth that are hidden from the users as a way of using replication to back up files to other servers that users don't have access to. It's sort of a poor and expensive way to copy files without doing a traditional backup. It does work, but it is not the best way to do it, especially because it won't allow you to do a bare metal restoration. But it is an option, so you can use one or the other or both together. File replication services are very similar to DFS. The difference is that file replication services replicates Active Directory. That's all it does. It doesn't replicate files like DFS does for the users. It just replicates usernames, passwords, resource information, that kind of thing. So FRS makes it possible to synchronize data across the enterprise and is in fact the synchronization technology used by Active Directory. FRS is used to replicate Active Directory, whereas DFS is used to replicate files and folders. So if your FRS service is shut down on one of your domain controllers, that means that you're not getting synchronization of Active Directory. And that basically means that if you add a user in one domain controller, it will not replicate with the other domain controller, and that could cause a problem. File servers provide the central locations for storing and sharing files across the network. When many users require access to the same files and application data, you'll need to configure file servers throughout the organization. So you can create a file server on any Windows Server 2012 server. We talked about the two different DFS components, DFS namespaces and replication. One allows you to share a name, the other allows you to replicate those folders back and forth between each other. File Server Resource Manager, services for network file system, data deduplication, ISCSI Target, share and storage management, and Windows search service. So we'll talk about those. So FSRM defines file screening policies, allows you to block unauthorized, potentially malicious types of content. So if you don't want an exe file to be put onto your server that could be a virus, you can block all exe files except for ones that you manually override. Resource Manager disk quotas. You can manage disk space usage by folder and by volume. So you can say that if you don't want people to fill up your hard drive space on your servers, then you can limit how much hard drive space they can use. That's what FSRM is. It generates storage reports also, where you can generate storage reports as part of the disk quota and file screening management. NFS allows connectivity to Unix file services. Unix data can be set up to users as shares. So if you install NFS on your Windows server, you can then use that to create Windows shares that link back to the Unix servers. Data deduplication is a new thing for Windows Server 2012. It's been around with backups for a long time, but it allows you to save a lot of space on the server. So when more than one file with the same data is found, it keeps just the one copy. So if it sees 100 copies of a file, for instance, it will keep just one of those copies, and it will have the other files deleted, and it will just have pointers back to that one original copy. To the user, you can't tell the difference. Now, an ISCSI Target, and this is some new features that Microsoft has come out with in 2012. 2012 servers can connect to an ISCSI SAN Target. 2012 servers can also be used as an ISCSI SAN Target. ISCSI targets show up as hard drives on other servers. They can also be clustered for redundancy. So this basically means that the server itself can be an ISCSI SAN target. You can attach hard drives into the server, and it can be the SAN target for other servers. The targets show up as hard drives in other servers. We won't be doing this particular task in this class, but it is something that you will see in other classes. File and storage services, the primary tool to manage storage and file shares. A snap-in is included in Computer Management and Server Manager. It can be added to any custom MMC you create as well. So the MMC we created in the last lab, you can add file storage, manage storage and file shares from that as well. Basic and dynamic disks. Basic disks use the same disk structure as earlier versions of Windows. Limited to creating 4 primary partitions per disk or 3 primary partitions and 1 extended. With an extended partition, you can create 1 or more logical drives. So that is what a basic disk is, also known as basic volumes. Dynamic disks are different. They were introduced in 2000 as a way to improve disk support by requiring fewer restarts after disk configuration changes. All volumes on dynamic disks are known as dynamic volumes. You can do a lot more with dynamic volumes than you can with basic ones, such as you can add in RAID and that kind of thing. So let's talk about simple volumes. That's a volume that's on a single drive. It has the same purpose as a primary partition. So this is just the default type of volume that shows up. Spanned volumes are volumes that span multiple hard drives or can be on a single drive without needing to be contiguous. Striped volumes is a volume that uses RAID 0 to combine multiple disks into a striped set. So these are all only available with dynamic volumes. Mirrored volumes, another dynamic type of volume, is a volume that uses RAID 1. It mirrors information from one drive to another for redundancy. Or you can use RAID 5, a volume that uses RAID 5 to create a fault-tolerant striped set on 3 or more disks. Storage pools allows the creation of a single volume from a group of disks that can also be redundant. Encrypting file system. For encrypting files and folders, this does not encrypt the entire hard drive. It just encrypts individual files and folders. So if you install this particular server role, then you'll just be able to encrypt individual files and folders. Users can protect sensitive data so that it can be only accessed using their public key certificate. So you can override this with your administrator. The administrator always has the ability to override that. Encryption certificates are stored as part of the data in a user's profile. It doesn't safeguard the computer from attack by someone who has direct physical access. TPM is a microchip that has been around for a few years, and it is embedded into the motherboard, and you can use that to encrypt the hard drive. So if the chip is ever separated from the hard drive, then the computer will become unusable. So computers running Server 2012 can use a TPM to provide enhanced protection for data to ensure early validation of the boot file's integrity and to guarantee that a disk has not been tampered with while the operating system was offline. So if someone steals your server and they take the hard drives out and put them in another computer, they will not be able to use them because the chip on the motherboard has been used to encrypt those files on that hard drive, and the two cannot operate without each other. BitLocker is something that is more software-based rather than hardware-based. So the TPM is more hardware-based. BitLocker is software. So it's a feature included in all editions of Windows Server 2012. It's designed to protect the data on lost, stolen, or inappropriately decommissioned computers. Without BitLocker drive encryption, there are a variety of ways a user with direct physical access to a computer could gain full control and then access the computer's data, whether that data was encrypted with EFS or not. So what BitLocker does is it encrypts the entire hard drive. So even if the drive is separated from the computer, it's done with software rather than the TPM, but it can work with the TPM should you choose to configure it that way. So with BitLocker, you can now be safe in case your hard drive is stolen. It's designed to prevent all access to computers' drives except by authorized personnel. FAT volumes, these are the original file allocation table volumes that were used with computers, but FAT still has some uses in today's technology. So FAT has the following disadvantages. You can't control local access to files and folders using Windows file and folder access permissions. You can't use any advanced file system features, so it's got a lot of limitations. You can't use compression, encryption, disk quotas, or anything else like that. But it does have one good thing, and that's a good choice to copy to Linux and Unix file systems. So for instance, if you want to copy a file from, say, a Macintosh to a Windows computer using a thumb drive, then you'll want to format that thumb drive with FAT rather than NTFS, and that will allow you to copy that data between the two devices. NTFS is an extensible file system. It means it can be extended over time with various revisions. And it's also a recoverable file system, so you can use things like volume shadow service and file encryption, that kind of thing. Instead of using file allocation table, NTFS uses a relational database, the master file table, to store information about files. The master file table stores a file record of each file and folder on the volume, pertinent volume information, and details of the MFT itself. You can do these things with NTFS. You can use advanced file and folder access permissions. You can use file sharing and full control remote access to files and folders. You can use long file names, so you're not limited to the short 8-character names. You can use up to 255 characters. And you can use Unicode characters in file and folder names. These are normally ones you could not use in a FAT type of partition because they were also seen as programmer codes. You can use upper and lowercase letters, and you can't use NTFS with floppy disks, but you can use NTFS with removable disks, such as DVDs, CDs, thumb drives, that kind of thing. Disk quotas. This is a feature where you can tell how much data a person can have. So it's a built-in feature of NTFS that helps you manage and limit disk space usage. Using disk quotas, you can monitor and control the amount of disk space people who access the network can use. Disk quotas are configured on a per volume basis. When you enable disk quotas, all users who store data on that volume will be affected by the quota. So let's just take a quick look at a disk quota, for instance. And what we'll do is we'll just open up Windows Explorer, click on Computer, we'll right-click on the C drive and go to Properties. There is a tab that says Quota on it. If we enable Quota Management, then we can limit the disk space to whatever size we want. We can go all these different sizes here, and don't limit the administrator to this, by the way, because you could definitely have a problem where Windows would no longer be used properly. You can also deny disk space to users exceeding that quota limit. So if they go above that amount, then a message will pop up saying that you can no longer use the server. You can log the events when those things happen as well. If you click on quota entries, it'll tell you who has what space on the server at that time. And if you want, you can go to properties and you can choose limit disk space to particular users and that kind of thing. So this is the one for the administrator itself. So you can, anybody who's an administrator, if you go to properties, you can say do not limit disk usage. We also have shadow copies, where if we turn on shadow copies, then it will save the previous versions of any files that are created. And you can go to previous versions to see that list of files that have been altered. So if you have an Excel file you've made changes to 20 times, then you'll see 20 different Excel files up to the maximum amount of space that it can use before it starts overwriting that 20th file. So you can go, if you see that file in here, you can click on it and then you can choose restore, and it will restore over the one that the user sees in the folder. Disk quotas can be configured to generate warnings and or enforce the limits by denying disk space, which I just showed you. As users create files and folders on a volume, an ownership flag is applied and the space used counts towards the user's quota. There is no way to set a specific limit for all volumes on a server or across the enterprise. So what that basically means is that every single drive letter that you see here, you have to set individually for the disk quotas and also for the previous versions. All space used on a volume counts towards the disk quota, even data in the recycle bin. So if there's the data in there, that also gets counted. By default, disk quotas are disabled, but you can enable them the way I just showed you. And before you configure disk quotas, think carefully about the limit before you have people calling and screaming at you. A couple of different file sharing models that Windows Server 2012 supports: the standard file sharing and the public file sharing. So standard file sharing is anytime you go into a folder, right-click on it, and choose to share the file or the folder. Public file sharing is a type of file sharing that's included in Windows as soon as you turn it on. And basically the users folder under the C drive by default is where the public file sharing exists. So if you click on the C drive users, then basically anybody who logs into this server is going to get a folder that automatically is created, and they are the only ones who have access to it along with the administrator. There's no other folder on the server that will do that kind of thing. All right, so if you want to do the file sharing, it's only available on disks formatted with NTFS, so FAT is not going to work. Two sets of permissions determine who access the shared files. You have NTFS permissions, which is the security tab, and the share permissions, which is the share tab. All shared folders have a share name and a folder path. When network discovery is enabled, users can browse the network using Network Explorer to find those shares. You can create hidden shares. These are shares that are there only if you know the actual path name, by adding a $sign to the end of the share name. So if we were to make a share called software that we wanted hidden, it would be called software $. By default, when you create a share, everyone with access to the network has read access. You can change that if you'd like. The C drive, the D drive, the E drive, and any other drives all have these special hidden shares automatically created. There are also some other shares that have the $sign in front of them, such as the admin share for accessing the system root. Net logon share is used by domain controllers, and sysvol. Now, sysvol and net logon folders are going to be shares that you only see on domain controllers. So, for instance, if I pull up our Windows Explorer and I click on Network, and I put in DC01, then I'm going to see sysvol and netlogon. These are two shares that only show up on domain controllers. Now, netlogon is a subset of sysvol, but it doesn't look that way. It looks like they're two separate folders, but the reality is under sysvol, you're going to see scripts, which is the netlogon folder. That's the same as this folder. So if I create a text file here, and I go back to sysvol scripts, that same file shows up. So if you don't see those two and you have a domain controller, that means the domain controller is not working properly. So there are certain methods for creating shares. You can use Windows Explorer, you can use computer management, you can use file and storage services, or the netshare command line. Share permissions are applied anytime you access a file or folder over the network. The share permissions available are as follows. Full control, users can do everything. Change, users can do everything, but they cannot change the permissions. And then read allows you basically to read the file, but you can't make any changes. Now, inheritance is a big part of sharing files and folders. By default, when you add a folder or file to an existing folder, the folder or file inherits that permission. So you can remove those inheritance if you'd like. Inheritance is automatic. If you do not want the permissions of subfolders and files within folders to have that, you must override the inheritance. Basic folder permissions. You've got full control. These are the NTFS permissions rather than the share permissions. So you've got full control, which allows you to do everything, including change the permissions. You have modify, which allows you to do everything except change the permissions. And then you have list folder contents, permits viewing and listing files and folders. Read and execute permits viewing and listing of files and folders, as well as executing files. So if it's a program, you're definitely going to want to have the execute permission. Write actually allows you to make changes to those files. And read permits viewing and listing files and folders. So read by itself allows you just to read, but read and execute allows you to read. And if it's an application, you can also run that. All right, so you've got full control, modify, read, and execute. These put together allows you the various different permissions that we just discussed. You can also audit the file and folder access to track who accessed files and folders, what they did, and you must configure auditing for file and folder access to actually be able to see that. So to track these things, you have to enable auditing, you have to specify which files and folders to audit, and then you monitor under the security logs and event viewer to see what people did. So if you want to monitor who's deleting a file or changing a file, that kind of thing, you turn on the auditing, and then you can actually see who did those kinds of things under the security logs under event viewer. You can enable and configure using group policy or local security policy as well. So let's take a look at this kind of thing. We're going to go ahead and click on computer. I'm going to pick a folder. Let's go ahead and create a folder. We'll call it test. So under test, if we right click and we go to properties, we can go to sharing. Now you have a couple of options here. You can click the regular shared, or you can click the advanced shared. I like to click the advanced shared because sometimes when you choose the regular shared, it doesn't show up properly. Don't know why that is. So go ahead and click advanced sharing, share this folder, share name is test. Permissions, by default, everyone's going to have read access. If we want, we can choose everyone to have full access and click OK, and then click OK again. Under security, we can see that the creator owner, so the person who created it, which is me, has special permissions. You can see the system or the server itself has full access. Administrators by default are going to have full access, and all users by default are going to have read list. You have to have list in order to be able to find it. Read and execute in case it is an executable, which it's not. And then you have some special permissions as well. So if I wanted to give access to just a particular user, let's go ahead and go into Active Directory users and computers, and I want to give user 011 access to this. All I have to do is go into sharing and give full permissions, and then under security, click edit, click add, check names. Didn't find it under that one. There we go. And we'll find user 11. Oh, I had a space after it. That's why I missed it. Click OK. I'm about to add it and to a disabled object, but that's okay. And I'm going to click full control, click apply. So what happens is it takes the full access under sharing and the full access under security, it adds them together and it takes the most restrictive policy. In this particular case, they're both set to full. So that means I have full access. However, if I uncheck these different things, and let's just say I give read access only. So under share, I have full access. Everybody has full access. But under security, I have read only. You add those two together, and whichever is the most restrictive, that is the rights. So in this particular case, you have full versus read only. Read is more restrictive than full, so read is what user 011 is now going to have access. So that's how file and folder permissions work. Shadow copying, two important independent features. Shadow copying of files in shared folders allows you to configure volumes so that shadow copies of files in shared folders are created automatically at specific intervals. This is what we did with the previous versions tab earlier when I right-clicked on the C drive and went to Properties. And you saw previous versions after I enabled the shadow copy service. The other thing that shadow copy is good for is it allows you to copy open or locked files. So if you open a Word or an Excel document, you've locked that file. So if you try to back up that file and make copies of the file, it won't let you do it. However, if you turn on shadow copying, then you will be able to do it because it makes a shadow copy of that file. Designed to help recover files that were accidentally deleted, corrupted, or inappropriately edited. Users are able to recover files and folders without needing assistance. They'll actually see previous versions show up when they right-click on the folder inside their own computer. After you configure shadow copying, you must install a client on computers throughout the organizations. That's only if they have older versions. And now Windows 2012 and Windows 8 allows you to not have to install this special client. Shadow copy service will save up to 64 versions of each file, so you can change that 64 times, or up to 10% of the volume of the hard drive. If a volume runs out of space, shadow copying will fail and errors will be generated in the event logs. So if for some reason something gets corrupted, then you'll see that in the event logs. So in conclusion, we talked about data storage, file and storage services, installing configured file services, DFS, other services for file, and then disk management, basic and dynamic, encrypted file services, TPM, BitLocker, FAT, NTFS, disk quotas, sharing, file sharing models, permission inheritance, basic folder and file permissions, and how to audit file and folder access, volume shadow copy service, and shadow copies of shared folders.